Alright, let's look at quadratic models. I'm going to give you guys just a second, so might want to hit pause here. Again, usually whenever you hear us say model, we're talking about some sort of relationship to the real world. So word problems, things like that. So we're modeling a specific situation. Alright, so let's look at this data right here. The table below lists the average time spent driving each day by various groups. So in the age group 15 to 19, we're actually going to use the median age, which is 17, and their average drive time per day is 25 minutes. 20 to 24, we're going to use 22 and 52 minutes. So the table actually winds up being like that. So we're going to use those two data points, or those two columns there. Alright, so the black dots on this page represent each of the data points. The blue line in this case represents the model that a computer or graphing calculator came up with to best fit this data. Notice how not all of those actual data points fall on the blue line. That's okay. The calculator is just saying that the blue line is the best possible fit for this data. Alright, so with that information, we're going to move on to these questions. Estimate the average daily driving time of 22-year-old drivers. Okay, so again, our years are our x-axis, and so whenever they say estimate, we're actually looking at what we think would happen on the blue line. So 22 is approximately right here. So I'm going to go up here to the blue line, and I'm going to say maybe, we can only approximate, so maybe 45 minutes or so. So on number 1, I would say approximately, that's what that symbol means, 45 minutes. Then they say, what was the actual average daily driving time of 22-year-old drivers? Well, that comes from our table. The actual is 52. And so then it says compute the error in the estimate. Well, the error comes from the actual minus your estimate. So the error is approximately a 7-minute error. That's okay. It happens sometimes in math. Then number 3 says, estimate the ages of drivers whose average daily driving time is 56 minutes. So I'm going to go back here and I'm going to look at 56 minutes. So here's 50. 55 is about right here, so 56 minutes slightly above that. And notice how that blue line hits it at 2 different locations, right here and right here. Okay, so I'm looking for the ages, so I don't know, 28, 29 or so, and then going down here to a little over 60 years old. So let's just say 28 years old, and let's say 62 years old. Estimate the ages of drivers who spend the most time driving. The most time driving is going to be our peak right here. So about what age is that? It is about 43. So approximately 43 years old. If you said 42, nobody could argue with you on that. Number 5 says find the A-intercepts, and what do they mean in this situation? The A-intercepts are, let me just erase some of this mess here. The A-intercepts are where that graph crosses or touches the A-axis at. So they are right here and right here. And what those two ages mean, which is less than 10 years old and more than 80 years old, they're saying those people drive 0 hours per day or minutes per day. Well, I hope 9-year-olds drive 0 minutes per day. But if you look on this graph, it says that 10-year-olds drive about 10 minutes a day. So notice how graphs don't always work out perfectly. In this case, we know that 10-year-olds don't drive. So you actually had a graph breakdown at that point. So this is a decent graph from about here to here. But other than that, you pretty much get a graph breakdown. Okay, I think we said 43 here. They're saying 45 and 68. Without an actual graphing calculator or computer to run this data, there's no way that we would have those exact numbers without those tools. So the best you can do with what you're given is estimate. And see here they're saying that 7 and 83. And now right here they're talking about the model breakdown. And it's saying that there's a breakdown again for 83-year-olds because it's saying 83-year-olds don't drive. Well, there are some 83-year-olds that still drive a car. So again, your model tends to break down at some point, and graphs are usually only good for a small piece of it. Okay, it says here, by graphing the scattergram of the data, you can determine whether to use a linear, a quadratic, or neither. And the thing is, whenever you're using a graphing calculator, you have to tell it that, oh, I want the linear model or I want the quadratic model. And so what you do is you have it plot the points and you decide from that point on, do I want the linear or do I want the quadratic? And the calculator will do that for you. Okay, all right, so that's it for this lesson. If you have any questions, let me know.